where are you from? Now, you might answer Mexico or Manhattan, France, or Fort Worth. Whatever your answer, we are all, each of us, of alien origin. Now, I'm not saying we are like little green men. I work at the Perot Museum of Nature and Science. I'm a planetarian there, so I kind of have a reputation to uphold. What I'm going to tell you is not science fiction. It's actual science. I'm standing right now outside under the stars in order to find out where we came from, meaning the parts of our bodies like carbon, oxygen, iron. In order to understand where these elements form, we have to leave the Earth and look up at the stars. There is no force on this planet strong enough to smash light elements like hydrogen together and fuse them into the building blocks of our bodies. Now, what is this force that stars have that allows this building block of elements to happen? Well, it's a force you're all very familiar with, gravity. The same force that keeps you from floating up into space. Gravity is kind of a weak force. That means things aren't going to stick to you. According to John Hakila, and the genesis of the modern universe, gravity is the force that draws mass together. Now, the more mass something has, the more gravity it has. Of course, the Earth has much more gravity than you do, so when you drop something, it falls down to the Earth instead of sticking to you. A star has way more mass than our planet. Our sun, for instance, has about 300,000 times the mass of the planet Earth. Now, what that gravity does is it's pulling mass together, smashing it in. As that happens, you can imagine the temperature increases. It gets hotter and hotter. This is called thermal pressure. And that pressure is pushing out. Crush of gravity, pressure pushing out. According to Facts on File 2007, when the temperature reaches 15 million degrees Celsius, it's hot enough that elements like hydrogen start fusing together. When that happens, it releases a tremendous amount of energy. And that star, for most of its life, stays balanced. It's this cosmic dance between the crush of gravity and the release of energy. But what happens when the star finally exhausts its hydrogen fuel? It doesn't have anything pushing out, and so the star is going to collapse in on itself. Now, according to Paul Murden of the Canopus Encyclopedia of Astronomy, this starts a whole new series of reactions which form carbon, oxygen, nitrogen, all the way up into iron, which ends the fusion cycle. Iron is a very stable element. Jim Keller continues on in his 2010 article in Astronomy magazine, and I'm just going to quote this here. When a supermassive star that's something maybe 100 times the size of our own sun gets to iron, the end of the fusion line, they blow up as a supernova, creating nearly all of the other elements in the periodic table. This detonation scatters the elements out into space in interstellar clouds of gas and dust, out of which new stars and planets form. Right here where we're standing, about 4.5 billion years ago, that's exactly what happened here. Our planet, the other planets, and our star, the sun, formed out of a cloud of waste products from other stars that had exploded. The carbon, iron, oxygen in our bodies, the gold on our rings, all of these elements formed in stars. So truly, no matter where we live on this planet, our origins are from space. This is Kyle Doan of the Perot Museum of Nature and Science, wishing you all peace and prosperity.